Yes. You are welcome back again to Sir Josh Made Maths Simple. Yeah. Um, we are going to solve more examples on our log 1 to 7. Log 1 to 7 of indices. In our last class, we talked about indices. We discussed on log 1 to log 7 on indices. So today we are going to look at more examples, because after these examples, our next video is going to be on exponential indices. And after exponential indices, we are moving to what? To logarithms. Now, let's quickly work on this now. Now, I'm going to take it one after the other. Now, on here now, question number 1 here is 0.25 minus 1 over 2. Now, when you look at this, you should look at it very well. This is a kind of this is a decimal number. A decimal number, not up to 1. Yes, not up to 1. Now, when you want to solve this, you have to make use of something. And what is that you have to do? You have to convert. Take notes. You have to convert your decimal number to what? To fraction before you can start solving. And let me quickly teach you how to convert your decimal number to fraction. If you are having 0.123, and I am called to come and convert this to fraction, this is what I'm just going to do. After the points, I'm going to count. After the points, I'm going to count. And how many numbers can I count after the points? We have 1, 2, 3. How many number is that? 3. So I'm going to say to fraction is 1, 2, 3 over the number of numbers after the points will determine the number of zero at the denominator. Let me repeat that again. The numbers of number after the points will determine the number of zero at the denominator. So here, after a point is 3, 1, 2, 3. So that 1 to 3 is telling us that we are going to have how many zero now? 1, 2, 3. Let's look at this. 57.32 to fraction. 57.32 to fraction. That will be 5732 over 1, 1, 2. 1, 2. Can you see that now? So we are converting this to fraction now. So converting this to fraction first before you solve. So here we have 0 to 5. We have what? 25 over what? 100. 100. Why is it 100? 1, 2, 1, 2. Can you see it? 1, 2, 1, 2, 100. Now we have this as minus 1 over 2. Yes, minus 1 over 2. Now let me quickly explain one kind of short techniques to you. One kind of a short techniques to you now. You see, the techniques here, it is. I just discovered this now. It is a law that I discovered myself. Now let me just show you. Josh, 8th law of indices. This is Josh. This is Sir Josh. 8th law of indices. And I during the course of this, I'm going to introduce more laws to you. The 8th law of indices is just is gotten from this law. When you look at this question is basically from the law 7 of indices, but I want to introduce more law to make our calculation here more simpler. The law I am introducing now is if you are having A over B all minus C over D. Please take note of something. The base is a fraction. Can you see? The base is a form of fraction. Then the power is a form of fraction, but we are having a negative what? Power. We are having a negative power. Now, here we are going to say whenever, please look at this law, the eighth law. Whenever you are having a negative fraction, a negative power rather, whenever you are having negative fractional power on a base, when you want to solve, the base is going to what? Turn upside down. Then you eliminate the minus. That means I am going to say that this minus now will make this base turn upside down, which is going to be b over a or c over d. Can you get something there? So we are going to apply this law to this. So I'm going to solve this question in two formats. I'm going to solve this question now using the what? Using the negative power law of indices and using law 7 of indices. Then I'm now going to solve this using Josh's law of indices. Now let's use the normal law of indices I introduced to us. Now using the normal law of indices I introduced to us, we have, I told you that whenever you're having negative here, what will happen to the negative? The negative will turn to 1 over. Always take note of that. So here is minus. So we have what? 1 over 25 over 100. Then all in brackets. What is our power here? 1 over 2. Now here we have equals to 1 over, mind you, what is the power? The denominator of the power is 2. So we have the root of what? 25 over 100 or 1, which will give us 1 over, what is the root of 25? What is the root of 25? Is what? Is 5 over, what is the root of 100? Is what? Is 10. Now, here is 10, so we are going to have 1 divided, no, this 1 divided by 5 over 10, which will give us 1 times, by the time you are changing division to times, when you are changing division to times, this is going to turn upside down, which will have 10, over 5. So when I cancel, we have what? 1. We have 2 over 1, which is 2. Can you see the processing we take in solving this question? Can you just see the processing it takes us to solve this question? Can you see the processing? Now, let's use Josh's law, Sir Josh's law of indices. Now, using Sir Josh's law of indices to solve anything like this, now we are going to compare and contrast. This is 25 over 100. This is minus 1 over 2. Now, using Sir Josh's law of indices, mind you, I told you, whenever you are having a negative sign here, a negative power here, and the base is fraction, remove the power and turn the base upside down. So removing this power now and turning the base upside down will just give me what? 100 over 25 and 1 over 2. Can you see? I've cut this away. Then here we come to say what is this is 2, so we have root 100 over 25, all 1. What is the root of 100? 10 over 5, all power of 1, which will give me 2 over 1, which is 2. Can you see? It is this law will escape you through from this scenario. Now, let's look at question number 2. Looking at question number 2, let's look at question number 2. Looking at question number 2, we have 50 over 32 on 1 whole number 1 over 2. Now, looking at this power, the power here is in form of what? Mixed fraction. The power is in form of what? Mixed fraction. Now, first thing, convert the fraction to what? So improper fraction, we have here is 50 over 32. Then we have minus 2 times 1 is 2, plus the numerator 1 is 3, 3 over 2. Now, this over 3 over what? Over 2. Now, here we come to say the minus here returns 1 over, then we have 50 over 32, bracket of what? 3 over 2. Then here we say we have 1 over the root of 50 over 32 all cube. Now, looking at this now, is there a number we can multiply? Now, this is root. And I told you that root is mathematically telling us that what is 2. So is there a number I can multiply 2 times? 2 good times that will give me 50. Number multiply 2 times that will give me 50. No! Okay, good. Is there a number that I can multiply 2 times that will give me 32? No. So what else will I do? Think. Good. What I can do is what I will now divide these 2 numbers till I get what I'm looking for. Good. Then start my division. Saying 2 here is what? Okay, let's divide it outside the box to make our calculation more simple, more clearer. 2 in 50 is 25. 2 in 36 is 16. Are we getting it now? We are getting it now. So let's look at the root of 25 and 16. The root of 25 and 16. Now I can get that 2 numbers that I can multiply together to get 25, and that same 2 numbers multiply together to have what? 16. That is what? 5 times 5 will give me what? 25, and 4 times 4 will give me what? 16. So I'm going to use that to this, saying 1 over root 25 over 32 cube will now give us 1 over what? 5 over 4. Oh, no. And error has been detected here. So this should be 16, not 32. 16. So here we continue by saying 1 over 5 times 5 times 5 over 4 times 4 times 4. Why? Because it is the power of 3. So we have 1 over 5 times 5 times 5. That is 125. 125 over 4 times 4 times 4. That is what? 64. So we have 64, which we have as what? 1 over 1 divided by 125 over 64, which we have 1 times 64 over 125. So is there any division? Is there any way we can divide? We have 64 over what? 125. Now, let's use Josh's law of indices for this now. Now, let's use Josh's law of indices to solve this aspect, and let's see if we are going to get the same answer we solve on. Here is 50 over 32 all minus 1 over 2. Now, Josh's law of indices, first thing you are going to convert 50 over 32 minus 3 over 2. Now, just law of indices said remove the minus and turn this upside down, which we have 32 over 50 bracket 3 over 2. Then divide till you get what you are looking for. So we have 16 over 25 or 3 over 2, which will now give us the root of 16 over 25 all cube. That will be 4 over 20 over 5, which we all cube, which will give us 64 over 20 over 125. Can you see? Good. Now let's move to number 3 of our question. Number 3 of our question. Number 3 of our question. Question number 3, 36 1 over 2 times 64 minus 1 over 2 times 5 raised by 0. Now, you see, we can solve this question in a diverse ways. Yes, we can solve this question in diverse ways. You can decide to use log 1 and log 2. You can decide to use log 1 and log 4. You can decide to use any of these laws, knowing that you know the words, you are applying the law very well. Now let's solve. I'm going to solve in 2 ways, applying laws in different ways in 2 ways. Now here, this is just let's use this law that says the denominator will come as a root. So write root 36 1 times, this is minus here, 1 over 64, 1 over 64 raised by 1 over 2. The minus has turned to 1 over. Are you with me? So we have times 5 raised by 0 class is what? 1 here. So we have, what is the root of 36? Is 6. 6 times 1 over the root of 64 whole 1 times 1. So we have 6 times 1 over, what is the root of 64 is what? 8. 8 times 1, which will be 6 over 8. 2 here 3, 2 here 4, which we have 3 over 4. Do you just see? Then I can decide to solve, or I can decide to solve applying my law in another format. In what way can I apply my law in another format? I can decide to say, since this is 36 1 over 2 times 64 minus 1 over 2 times 5 raised by 0. Looking at this 32, I can convert 32 to base of 2. I can convert 64 to base of 2, making these two same base. Now, convert 36 to base of 2. That means, what number is that number I can multiply together to have 36? Let's check it out. 2 times 2, 4. 4 times 2, 8. 8 times 2, 16. 16 times 2, 32. 32 times 2, 64. There is no number. Very sorry for that. Very sorry for that. So here we still have the root of 36 times. Here is minus. Mind you, we brought it down, but we can say the root of 64 all minus 1 times 1. Here is 6 times, what the root of 64? 4 minus 1 times 1. So we have 6 times 1 over 4 times 1. Then we have to what? Divide. Sorry, here is 8. Here is 8. So we have to divide by saying 4 and 3, which will be 3 over 4. So I'm just trying to use this to tell us that the questions will determine how to use the law, or the law will determine how to solve the problem. In any format the question or the problem is being brought to you, you have to look at it very well and understand how to apply those laws to it. Now let's look at the fourth question. Now, the fourth question is, we have 27 1 over 3 over 64 minus 1 over 6. Minus 1 over 6. Okay, good. Let's solve. This will give us, we've already known that it's going to be 3 root 27 all 1 over here. We know here is going to be what? 1 over, the 6th root of 64 all 1. What number can we multiply 3 times? That will give us 27. That is 3. 3 times 3 is 9. 9 times 3 is 27. So we have 3 over 1 over. What number can we multiply 6 times to give us 64? That is 2. So we have 2 raised by 1. So we have 3 over 1 over 2, which will give us 3 divided, which is this, divided by 1 over 2, which will give us 3 times 2 over 1, because by the time you are changing the times, this division, this is going to turn upside down, which is what? 6. Let's look at the number 5 now. The number 5 question. The number 5 question is 81 over 16 all minus 3 over 4. Good. let's use just law of indices for this now. Let's use just law of indices. So here we are going to have 1. If we are using just law of indices, we eliminate this minus and this turn upside down, which will be what? 16 over 81 or 3 over 4, which will give us 4 root 16 over 81 all cube. Remember what I told you? The denominator will come as a root, then all cube of the what? Numerator of the power. Now, what number can we multiply in 4 times to have 16? What is that number? Is 2. 2 times 2, 4 times 2, 8 times 2, 16. That is 4. So we have 2 over, what is that number? I'll multiply in 4 times to give me 81. That is 3. 3 times 3, 9 times 3, 27 times 3, 81. So we have 3 over what? 3, which is 2 times 2 times 2 over 3 times 3 times 3, which is what? 2 times 2, 4, 4 times 2, 8. 8 over what? 3 in 3 places. That is what? 27. And when you decided to use, the 7th law of indices, this we have 1 over 81 over 16, 3 over 4, which will give us 1 over the root of 4th root of 81 over 16 all cubed, which will give us 1. The 4th root of 81 is 3 over, why the 4th root of 16 is what? 2 or 3, which will give us 1. 3 raised to power 3, 3 raised to power 3 over 2 raised to power 3 is 1 over 27 over 8. And we have 1 divided by, 27 over 8. Division turns to what? Multiplication, which is what? 1 times 8 over 27, which is 8 over 27. The Josh law of indices is only helping us out to skip this issue, because most students do have issue with 1 over this and 1 over something like this. So the Josh law of indices will help you to skip. Just remember that this negative we have to leave, and once this negative is leaving, this will turn upside Now let's look at the last question of this. Now we have 4 over 25 all minus 1 over 2 times 2 raised power 4 times 15 over 2 raised power minus 2. Now let's solve this now. Now using Jones law of indices, minus will eliminate. We have 25 over 4 1 over 2 times 2 raised power 4 times, this is minus here, eliminate 2 over 15 or 2. Can you see what we are doing here now? So using, this is a denominator of power of 2, that is the root of 25 over 4 times 2 raised by 4 times 2 raised by 2 over 15 raised by 2. What is the root of 25? 5 over 2 times 2 raised by 4 times 4 over 15 raised to power 2. That is 225. Yes, we have 225. Yes. Then let's divide. Good. We have 5 over 2 times 2 raised by 4. That is 2 times 2 4, 4 times 2 8, 8 times 2 16. So then to that it is what? 32 times 4 over 225. 2 we cancel this to be 2. 5 we cancel this to be 1. 5 we cancel this to be 45. So our final answer is, we have 464 over 45. So which we can convert to, we can decide to convert it to mixed fraction. Converting to mixed fraction, you having one whole number, and whatever you are having there. So I'm using this medium to invite to plead to our viewers